So now here at a party, hexagonal tables are placed together. And then they said, explain why S equals 4n plus 2 represents a number of seats that are available if you have n tables. So let's say that n equals 1. So let's draw a picture to explain that. So we would have one hexagonal table, and the number of seats would just be outside. So if you look here, we would have 1, 2, 3, 4, 5, 6 seats. So in this situation, if we did S equals 4 times 1 plus 2, that's going to be 4 plus 2, which equals 6. So that works. And if we did 2 tables, so let's draw that picture. We would have, if we counted the seats, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's look at our function. We would put in S equals 4 times 2 plus 2, or 8 plus 2, which is 10. So our function is modeling this, and we have to figure out, well, why? So if you look at this overall, on the outside, so to explain what happens here, where is this 4 times n coming in? So each table adds 4 seats here, and then this 2 represents this end seat. So every table, if you look here, these are the tables on the outside. So every table that you add adds 4 of these. And then we will call these like your head of the tables or the end tables. So you add 2 on the end. Now, what's the domain and range of this function? Well, it would make sense that n has to be greater than or equal to 1. And then technically you could go up to infinity, but we're probably going to have a finite number. So n just is greater than or equal to 1. You have to have more than one table to have a party. And then really, at some point you'd say, well, how big is your party going to be? So it couldn't go on infinitely, but theoretically it could. So now to do the inverse function, we would have to solve for n. So S equals 4n plus 2. So to now solve for n, you would subtract 2 from both sides. So S minus 2 is 4n. Then divide all sides by 4. And n equals the number of seats minus 2 divided by 4. So now how many tables are needed for the following number of people? Remember, that's going to be our number of seats here because this n is number of tables. So you do not plug n in there. You plug it in here. This is what if we have our seats is 94. So you just plug that in. So n equals 94 minus 2 over 4. Or I'm sorry, 94 minus, and then that would be 92 over 4. Which gives us 23 tables. So now if we plug in 95, we would say the number of tables is 95 minus 2 over 4. Now we can't have a quarter of a table, so we'd actually have to round that up to be 24 tables. You could try to scooch people in, but that would probably be uncomfortable for your guests. So this would be 23.25, or you would round that up to 24 tables. So what domain makes sense for the inverse function? So we would just say here for the inverse function, n is going to be greater than or equal to 1. Oh, I'm sorry here. For that would be, we're looking at the domain would be the x numbers or inputs. So the number of seats here would have to be greater than or equal to 1. So you could have one or more people seated at your party.